For problems 18 through 20, the directions say find the inverse of each of the following equations, use proper function notation. I'm going to start off by answering the bonus question. If you were to graph the original and inverse functions on the same set of axes, what would the equation of the line of symmetry be? So let's say we've got our x and y axes here. The line of symmetry has the equation y equals x because your x's become your y's and your y's become your x's. So let's say our original function is this graph right here in red. Our inverse is going to be the same shape but reflected over the line y equals x. So it's going to look something like this. And so algebraically, in order to get that inverse equation, we need to switch our x's and our y's and solve for y. If you don't see a y in your equation, that's okay. With function notation, this is interchangeable with y. So for 18, we can write this as y equals 3x minus 1. And then what we'll do from here is we'll switch the x and the y, so that this is x equals 3y minus 1. Now solve for y. So add 1 to both sides. Divide by 3. Okay, y equals x plus 1 over 3. Go back to function notation if that's what we started with. So f inverse of x. Okay, I am adding that little -1 to the f to indicate that this is my inverse notation. And let me write it below the equation a little neater. So f inverse of x equals x plus 1 over 3. Okay, for 19, we've got g of x equals x squared plus 2. I can write that as y equals x squared plus 2, and then switch the x and the y so that this is x equals y squared plus 2, and then we'll solve for y. We'll subtract 2 from both sides. X minus 2 equals y squared. To get the y by itself, we do need to take the square root of both sides. So y equals the square root of x minus 2. And then something to remember when you're taking the square root and you're working with these kinds of equations is we do need the plus minus here. Okay, I'm going to write my final inverse equation in function notation over here. So not y equals, but instead g inverse of x equals plus or minus the square root of x minus 2. Okay. For number 20, we've got h of x equals the square root of x minus 5 plus 7. Over here on the left, I'm going to write this as y equals root x minus 5 plus 7. Switch your x and your y. Solve for y. Start off by subtracting 7 from both sides. X minus 7 equals root y minus 5. Then to get rid of this square root, square both sides. The square root and the square cancel, and you're just left with y minus 5. On the left side, you can leave this as x minus 7 squared. You don't have to expand that. And then the last step would be to add 5 to both sides. So our inverse equation in function notation would be h inverse of x equals x minus 7 squared plus 5. If you were to graph these three equations with their inverses on the same set of axes, again, they'd be reflected across the line y equals x.